The first impact was already scheduled long before anyone understood what that really meant. In early 1994, astronomers pointed their telescopes toward Jupiter and realized they were no longer watching an unpredictable cosmic event. They were watching a countdown. A fragmented comet had already broken apart into a perfect chain of 21 separate pieces, each one locked onto a collision course with the largest planet in the solar system. The trajectory had been calculated, the timing was exact, and for the first time in human history, planetary destruction was not a surprise.
It was an appointment.
Across observatories worldwide, one image immediately changed everything. A strange string of bright fragments stretched through space like pearls hanging in perfect formation. This was Comet Shoemaker-Levy 9, except it no longer looked like a comet. Jupiter's gravity had already torn it apart months earlier, leaving behind a train of icy debris now falling directly toward the planet.
And every fragment was coming in sequence.
That was the part no one could ignore, because Earth had never seen destruction arrive on a schedule before. The countdown started the moment astronomers understood the geometry. Normally, asteroid impacts happen without warning. A sudden strike, a crater, the damage is already done before anyone can react. But this was different. Jupiter had become the target of a fully predictable extinction-scale bombardment. 21 separate impacts, precise timing windows. Scientists now knew exactly where each fragment would hit and exactly when each collision would begin. And suddenly, telescopes were no longer observing. They were waiting. The visual anchor kept returning, that fragile string of pearls suspended in darkness. At first, it looked beautiful. Then, calculations transformed it into something else entirely. Every bright fragment represented a separate atmospheric detonation carrying energy beyond anything humanity had ever produced. The safe assumption had disappeared. Space was no longer random, and the countdown kept shrinking. As July approached, observatories began coordinating globally. Facilities across Hawaii, Chile, Arizona, Europe, and orbit itself prepared for continuous monitoring. The impact window would last nearly a full week. Every fragment would strike in sequence as Jupiter rotated beneath them, each collision hidden and revealed depending on where the giant planet faced. Missing even one impact meant losing data humanity could never reproduce again. That pressure changed everything. For decades, planetary collisions had existed mostly as theory. Scientists understood asteroids could destroy worlds. But impacts remained historical evidence, buried inside craters and geological layers. Nobody had ever watched a planetary-scale bombardment happen live. Now the telescope network had become a global surveillance system aimed at one target. Because time was running out. Then the first strike arrived. Fragment A entered Jupiter's atmosphere moving over 130,000 miles per hour. It disappeared beneath the cloud tops almost instantly. For several seconds, nothing happened. Observatories remained silent. Data streams kept running. Scientists waited for visible confirmation. Then Jupiter erupted. A massive plume exploded upward beyond the visible cloud layers, rising thousands of miles above the atmosphere itself. The dark planet suddenly carried a wound larger than Earth. And the countdown had only just started. The string of pearls returned again, but now its meaning had changed completely. Earlier, it represented a broken comet drifting through space. Now each fragment had become a scheduled detonation, waiting its turn. 20 impacts remained. There was no stopping any of them. That realization became far larger than Jupiter itself. Because halfway through the event, scientists began confronting a terrifying implication. If astronomers could predict impacts years in advance, planetary destruction was no longer purely random chance. Civilization-ending collisions could arrive with warning. Long warning. And warning meant something uncomfortable. Knowing early changes nothing if you cannot act. That was the midpoint, where the story stopped being about Jupiter. Earth had no defense system, no interceptor programs, no kinetic impactors, no orbital response infrastructure. Humanity could calculate extinction years ahead of time while possessing absolutely no mechanism capable of prevention. Prediction had outpaced survival. And Jupiter was proving it live. As larger fragments approached, impacts intensified. Fragment G delivered the most violent strike yet. The explosion released energy estimated at millions of megatons. Massive black scars spread across Jupiter's cloud bands, each one growing darker against the planet's pale atmosphere. The visual anchor returned again. The string of pearls was disappearing, one fragment at a time. And each missing fragment left behind planetary wounds visible from Earth itself. That image changed scientific confidence permanently. Before Shoemaker-Levy 9, planetary defense had been mostly theoretical discussion buried inside research papers. After Jupiter, the conversation shifted. Governments and observatories began taking near-Earth object tracking more seriously. If Jupiter could suffer predictable annihilation on schedule, Earth could eventually face the same certainty. Except Earth would not survive the demonstration. That was the final realization no one escaped. The terrifying part was never the explosions erupting across Jupiter. It was the timeline. Humanity had watched extinction arrive days in advance with absolute certainty and discovered the most dangerous truth imaginable. Prediction is useless without intervention. The black scars eventually faded from Jupiter's atmosphere. But the meaning never disappeared. For the first time, destruction had a calendar. And Earth had no answer. Sometimes knowing is the worst part.